Good morning, students. Today we are going to discuss the solution of the revision that is given today. So today's first question is fill in the blanks. In the first question we have the center of the circle lies dash of the circle. The answer is interior of the circle. A point whose distance from the center of a circle is greater than its radius lies in the dash of the circle. The answer will be exterior of the circle. Number 3. The longest chord of the circle is a diameter of a circle. So your next answer is diameter. An arc is a dash when its ends are the ends of the diameter. So the answer to this question is semicircle. So the arcs of a semicircle when its ends are ends of the diameter. The last subpart of fill in the blank is segment of a circle is a region between an arc and the chord. So between arc and chord you will get a segment. So if this is a circle between and this is chord, AB is a chord where O is the center, then this portion is called the segment. Now question number 2 is true and false. So you have to write whether the following statements are true or false. The line segment joining the center to any point on the circle is the radius of the circle. The answer is true. Second subpart. A circle has only finite number of equal chords. The answer is false. As we know, we can draw infinitely many chords and so we can get infinitely many equal chords. Subpart 3. If a circle is divided into 3 equal parts, each is a major arc. So it is also false, since if a circle is divided into equal arcs, so if we divide it into equal arc, we will not get each major arc. Major means big, minor means small. So we will get arcs of equal length but not major arc. Next subpart. A chord of a circle which is twice as long as its radius is the diameter of the circle. So this is a true statement, as this is the definition of diameter. And the last subpart is sector is the region between the chord and the corresponding arc. So this is also false. We know between chord and arc is a segment, as I have shown it in the fill in the blanks. And sector is between two radii and an arc. So AO and BO are the two radii enclosed within an arc. This portion is called, the shaded portion is called a sector. Now let us see question number 3. In this figure we have angle ABC as 69 degree, angle ACB as 31 degree. We have to find angle BDC. So we have to find this angle. So let us see how to solve. So first we will consider the triangle ABC. By angle sum property of a triangle, we will get angle A plus angle B plus angle C is equals to 180 degree. So angle A is given as 69, angle C is given as 31. So if we substitute the values and subject angle BAC, that means this angle, we will get the angle A. So which is equals to 180 minus 100. So angle BAC is equals to 80 degree. Now if we see the shaded portion that is done in light blue color, this is a segment that we are considering. So the segment is BADCB. So the shaded portion is the segment that we are considering, and we know that angles in the same segments are equal. So angle at A and angle at D are both equal to each other. So by this theorem we can say angle BDC is equals to angle BAC. Therefore, angle BDC is equals to only 80 degree. So this is our answer for question number 3. Now let us see question number 4. If a line intersects two concentric circles with same center. So the concentric circle is a small one if we see this diagram, as well as a big one. This makes a concentric circle when we have a same point, that is center is O. A, B, C and D are the points where the line AD intersects with the circles. We have to prove AB is equals to CD. So let us see how to do this sum. Given AD is a line that intersects the two concentric circles at ABCD, where O is the center. We have to prove AB is equals to CD. So we need to construct a line from the center to the line AD. That is, OM is perpendicular to AD. Now we will start our proofing. We know that any line that comes from the center and falls on the chord bisects the chord as per our theorem. So AD is a line, or AD is a chord for the larger circle. In this large circle, if we consider this large circle, in this large circle you can see AD is a chord and OM is a line which falls from the center on the chord. So it will bisect the chord, so we will get AM is equals to DM. Now let us come to the small circle. In the small circle, BC is the chord and the line OM falls from the center on the chord. So we will get the line BC as bisected, that means divided into two equal halves. So we will get BM is equals to CM. Now we have two equations, equation 1 and equation 2. We will subtract equation 2 from equation 1. So we will get AM minus BM is equals to DM minus CM. So which implies AB is equals to CD, which is our required to prove. So our required to prove is done. Now let us see the next question. In the next question we have three girls, Reshma, Salma and Mandeep, are playing a game by standing on a circle of a radius of 5 meters drawn in a park. The Reshma throws a ball to Salma, Salma to Mandeep and Mandeep to Reshma. If the distance between Reshma and Salma and Mandeep is 6 meters, what is the distance between Reshma and Mandeep? So this is the question. Let us see the diagram and the sum. So we have a park. In the park is a 5 centimeter and Reshma is represented with R, Salma is represented with S and Mandeep is represented with M. Now let us draw a perpendicular OA on RS and OB on SM. We know that the distance between Reshma and Salma and Mandeep is 6 meters each. We have to find the distance between Mandeep and Reshma. So this distance we have to find. So AR is equals to RS, as we are drawing a line from the center of the circle on the chord RS. RS is a chord. So any line that falls from the center on the chord, it bisects the chord. So the 6 meter will be divided into 3 each. So AR is equals to AS is equals to 3 meter. And the radius of the circle is given as 5. So OR, OS and OM are all 5 meter. Now we get a right angle triangle OAR, as it is perpendicular. Line from the center is perpendicular on the chord. So we will get OAR as a right angle triangle, where O by Pythagoras theorem, so this is a Pythagoras theorem, PTHM. By Pythagoras theorem, we will get OA square plus AR square is equals to OR square. So OA square plus 3 square plus 5 is equals to 5 square. So if we subject substitute the value and subject OA, we will get OA as 4 meter. So the distance between the center and A, the point A, is 4 meter. Now you can see from the diagram that ORSM is a kite. Kite is a special kind of a quadrilateral where the diagonals of the kites are always perpendicular to each other and they form an isosceles triangle. So we can see that the OA, OR, OM, these two are equal as they are the radii, and RS and SM are equal as they are the distance between the friends. And the diagonal of this kite is perpendicular. So we get to know that angle ARC will be 90 degree. That the angle at C, that means this point, is 90 degree, and RC is equals to CM. So this line is very important for our sum. As we know, the triangles are equal and isosceles to each other. So triangle ORS, that is this portion, is equal to the triangle OSM, and their areas are also equal. So we can, since OA is a perpendicular, we can use half base into height, this formula for to find the area of ORS. So half of RC into OS, so this is the perpendicular and this is the base, is equals to half of OA, this line OA, and RS. So the triangle area is same. So we will get half and half cancels each other. RC into 5 is equals to 24. So RC is equals to 4.8. And previously from the figure we have seen that RC is equals to CM as it is a kite. So we will get RM, the distance between Reshma and Mandeep, is 2 times RC, which is equals to 9.6 meter. Therefore, the distance between Reshma and Mandeep is 9.6 meter. And today's last question is question number 6, where A, B, C and D are the 4 points in a circle. AC and BD intersect at a point E such that you will get angle BEC is equals to 130 degree and ECD is equals to 20 degree. So you have to find the angle BAC. So let us see how we have to solve this sum. So BD is a line. BD is a straight line. So BEC plus DEC is equals to 180 degree, which is a linear pair. So on substituting the value and subjecting DEC, we will get 180 minus 130, that is 50 degree. So as you can see, the angle DEC is equals to 50 and DCE is equals to 20. So by angle sum property, we will of a triangle, so we can get the angle D, that is the top angle. So substituting the values and subjecting angle EDC, we will get 180 minus 70. So we will add 50 and 20 and we will get 70. So 180 minus 70 is 110. So the angle at D is 110. Now angles, this portion is in the same segment. So BADCB is a segment and angle at D and angle at A are angles in the same segment. So whatever value we get for D, the same value will be for A. Therefore, angle BAC is equals to angle BDC, which is equals to 110 degree. So these were the sums for today's revision. I hope you have done very nicely in your revision work. Thank you.